Hello dear students, Assalamu alaikum. I hope you will be fine. My name is Engineer Mir Musudra. I am lecturer in Department of Technology, Sarhad University of Science and Information Technology, Peshawar. As I am teaching you the subject fluid mechanics, today is your lecture number 5. In lecture number 5, we will study about total force and total force on an immersed surfaces. First of all, we will study about total force. So, the total force on an immersed surface may be defined as the total force exerted by the liquid on it. Mathematically, total force P is equal to P1 A1 plus P2 A2 plus P3 A3 and so on. So, total force is the force which is exerted by the liquid on the surface, and it can be mathematically written as P. Total force P is equal to P1 A1 plus P2 A2 plus P3 A3 and so on, where P1, P2, P3 equal to intensities of pressures on different strips of the surfaces, and A1, A2, A3 are the areas of the corresponding strips. The total force on an immersed surface, we see that whenever we dive in a swimming pool, we feel some uneasiness. As we dive deeper and deeper, we feel more and more uneasiness. This uneasiness is in fact due to the total weight, or in other words, total force of water above us. Now, we shall discuss the total force exerted by a liquid on an immersed surface. As a matter of fact, the position of an immersed surface may be horizontal, vertical, or may be inclined. So, first of all, we will study about total force on a horizontally immersed surface. For this, consider a plain horizontal surface immersed in a liquid as shown in figure 3.1. As you can see, a horizontal surface is immersed in a liquid. Let omega is equal to specific weight of the liquid, the liquid in which the immersed surface is immersed, in which the horizontal surface is immersed. The unit weight or the specific weight is denoted by omega. A is the area of the immersed surface in square meter. A is the area of this immersed surface in square meter. And x bar is equal to depth of the horizontal surface from the liquid level in meters. This is the x bar value, and it is the depth of the horizontal surface from the liquid level in meters. Now we know that total force on the surface P is equal to weight of the liquid above the immersed surface. So the total force on this surface is equal to the total weight of the liquid above this surface. Weight of the liquid above the immersed surface is equal to specific weight of the liquid into volume of the liquid. When we multiply the specific weight of the liquid by volume of the liquid, we will get the total weight of the liquid, as the specific weight unit is kilonewton per cubic meter and volume is cubic meter. So cubic meter will cancel out with cubic meter and we will get kilonewton, which is the unit of force. So we will get the total force above the surface of the liquid. Also, the volume is equal to area of the surface multiplied by depth. So we get an equation P is equal to total force is equal to omega, which is specific weight of the liquid. A is the area of the surface and x bar is the depth of the liquid. By putting all these values, we will get the total force on the horizontally immersed surface, and where omega is the specific weight of the liquid in kilonewton per cubic meter. Now we will solve some example on the topic, and we have example 3.1. The statement of the problem is a rectangular tank 4 meters long, 2 meters wide, contains water up to a depth of 2.5 meters. Calculate the force on the base of the tank. The dimension of the tanks are given in the example, and we have to calculate the total force on the base of the tank. The length of the tank is given 4 meters while the width of the tank is 2 meters, and also the depth of the tank is 2.5 meters. So first of all, in solution we will write the given data. In given data, L is equal to 4 meter, which is the length, and P is equal to 2 meter, which is the width, and X bar is equal to 2.5 meter, which is the depth. Now we know that area of the tank, base area of the tank A is equal to length into width. So length and width values are given. Put the values and we will get the area of the base of the tank, which is equal to 8 square meter. And now total force on the base of the tank P is equal to omega AX bar. As the liquid is water, so the unit weight of water is already known, which is 9.81. A is already find out, which is 8 square meter, and depth is already given, which is 2.5 meters. So put the values in this equation, we will get the total force on the base of the tank, which is equal to 196.2 kilonewton. And this is the answer for example 3.1. Next is example 3.2. A tank 3 meter into 4 meter contains 1.2 meter deep oil of specific gravity 0.8. Find number 1 intensity of pressure at the base of the tank, and number 2 total force on the base of the tank. In the problem statement or example statement, the area of the tank is given, which is 3 meter into 4 meter. Also the depth of oil is given, which is 1.2 meter, and the specific gravity of oil is also given, which is equal to 0.8 meter, and we have to find the first intensity of pressure at the base of the tank, and number second we will find the total force on the base of the tank. First of all, we will write the given data in the solution, which is size of the tank A is equal to 3 meter into 4 meter equal to 12 square meter, and this is the area of the tank. The depth of oil X bar is equal to 1.2 meters given in the statement. Also specific gravity of oil is equal to 0.8, and specific weight of oil is equal to 9.81 multiplied by 0.8. By multiplying the specific gravity with the unit weight of water, we will get the specific weight of oil, which is equal to 7.85 kilonewton per cubic meter. Now first of all, we will find the intensity of pressure at the base of the tank. So we know that the intensity of pressure at the base of the tank P is equal to omega H. Already studied that P is equal to omega H, which is the unit weight and head. So unit weight is already find out, which is 7.85, and H is already given, which is 1.2 meter. So put the values and we will get the total intensity of pressure, which is equal to 9.42 kilopascal. In the second case, we will find the total force on the base of the tank. So we know that total force on the base of the tank P is equal to omega AX bar. So omega is already find out, which is 7.85, A is already given, which is 12 square meter, and X bar is already given, which is 1.2. So put the values and we will get the total force on the base of the tank, which is 113.4 kilonewton. And this is the end of, for example, 3.2. Now in the second case, we will find the total force on a vertically immersed surface. In the first case, we immerse a body or a surface horizontally and find the total force on it. Now the body is vertically immersed and we will find the total force on it. For this, consider a plain vertical surface immersed in a liquid as shown in figure 3.2. As you can see, a
plane vertical surface is immersed in a liquid. First of all, let us divide the whole immersed surface into a number of small strips, parallel strips as shown in figure. Here the surface is divided into small parallel strips, as you can see. Let omega is equal to specific weight of the liquid, and A is the total area of immersed surface, and x bar is equal to depth of center of gravity of the immersed surface from the liquid surface. Now we can calculate the total force on the vertically immersed surface by two methods. So first of all, by using first method, let us consider a strip of thickness Tx and width B and at a depth x from the free surface of the liquid as shown in figure 3.2. We know that the intensity of pressure on the strip and area of the strip is equal to omega into x. So we take a parallel strip. The thickness of the strip is dx and the width of the strip is b and the depth of the strip from the liquid surface is x. So total intensity of pressure on this strip is omega into x. Omega into x will give you the total intensity of pressure on this strip. Now area of the strip is equal to B into D. Dx is the B into dx. Dx is the thickness of the strip and B is the width of the strip. So multiplying these two components, we will get the total area of the strip. The force on the strip P is equal to intensity of pressure into area. By multiplying intensity of pressure with area, we will get the total force on the strip. So intensity of pressure is equal to omega x, which is taken from here, and area of the strip is equal to B into dx. So now total force on the strip P is equal to integral omega x into B dx. This is the total force on one strip, and this is the total force on the total force on the surface. So omega is constant since the unit weight of the liquid is constant. So take out omega outside of integral and we get integral x b dx. Since integral x b dx is equal to moment of the surface area about the liquid level and is equal to a x bar, so put this in here and we will get the total force P is equal to omega a x bar, which is same as in the case of when the body is immersed horizontally in the liquid, or the surface is immersed horizontally in the liquid. Now we will solve the same with the second method. The total force may also be found out by dividing the whole surface into a number of small parallel strips. Let A1, A2, A3 is equal to area of the strips and X1, X2, X3 is equal to depth of the corresponding strip from the liquid surface. Now we know that total force on the strip is equal to A1, omega A1, A2. This is the total force on first strip. Similarly, total force on the second strip is equal to omega A2, X2, and total force on third strip is equal to omega A3, X3, and so on. So total force on the surface P is equal to omega A1, X1 pressure on first strip plus omega A2, X2 pressure on second strip plus omega A3, X3 pressure on the third strip plus so on. Now here omega is common, so take out omega outside and we get A1 x1 plus A2 x2 plus A3 x3 plus so on. Now A1, A2, A3 and all the areas of the strip is equal to the total area of the strip, so which is equal to A, and x1, x2, x3 is equal to x bar, which is the depth of the center of gravity of the surface. So again the total force P is equal to omega A x bar, which is same as in the above case. So through this way we can find the total force by using this equation, the total force on the vertically immersed surface. Now we will solve an example on the when the body is immersed vertically. The statement of the problem is: a circular door of 1 meter diameter closes an opening in the vertical side of a bulb head which retains seawater. If the center of the opening is at a depth of 2 meters from the water level, determine the total force on the door. Take specific gravity of seawater as 1.03. So we have a circular door whose diameter is given, which is 1 meter. Also the depth of the center of the opening is given, which is 2 meters from the water level. We have to find the total force on the door, and the specific gravity of the seawater is also given, which is 1.03. First of all, we will write the given data. So d is equal to diameter of the door is equal to 1 meter given, x bar is equal to depth, which is 2 meter given, and specific gravity of seawater is already given, which is 1.03. Or specific weight of seawater is equal to omega into 9.81 into 1.03 equal to 10.1 kilonewton per cubic meter. Now we know that area of the circular door A is equal to pi by 4d square. So d is already given, which is 1. Putting the value of d, we will get the area of the circular door, which is 0.7854 square meter. And now the total force on the door P is equal to omega A x bar. Omega is 10.1, A is 0.7854, already find out, and x bar is given, which is 2 meter. So putting all the values, we will get the total force on the door P is equal to 15.9 kilonewton. And this is the answer of our example 3.3. Now in the third case, when the body is immersed inclinedly, we will find the total force on the surface, inclined surface. So we have the topic total force on an inclined immersed surface. Consider a plane inclined surface immersed in a liquid as shown in figure 3.4. This is the surface which is immersed inclined, means at an angle, the liquid. First of all, let us divide the whole immersed surface into a number of small parallel strips as shown in figure. The surface, the inclined surface which is immersed in the liquid, is divided into small parallel strips, as you can see. Let omega is equal to specific weight of the liquid, and A is the area of the surface, and x bar is equal to depth of center of gravity of the immersed surface from the liquid surface, and theta is equal to angle at which the immersed surface is inclined with the liquid surface. Now let us consider a strip of thickness dx, width b, and at a distance L from O, a point on the liquid surface where the immersed surface will meet if proceed. We know that the intensity of pressure on the strip is equal to omega L sine theta. We take one strip whose thickness is dx and width is b, and the total intensity of pressure on this strip is equal to omega L sine theta. In this equation, omega is the unit weight of the liquid and L sine theta is the depth. Since sine theta is equal to perpendicular divided by hypotenuse, so here in this case we have x bar perpendicular and hypotenuse is L. So sine theta is equal to x bar divided by L, and x bar is equal to L divided by multiplied by sine theta. By multiplying the hypotenuse with the sine theta, we will get the perpendicular height or depth, which is x bar. So the total intensity of pressure on the strip is equal to omega L sine theta. Similarly, area of the strip is equal to b into dx. The thickness when multiplied by width, we will get the area of the strip. The force on the strip P is equal to total force on the strip P is equal to intensity of pressure into area. When the intensity of pressure is multiplied by area, we will get the total force on the strip. The intensity of pressure on the strip is equal to omega L sine theta and area is equal to B dx. So we get the total force on the strip is equal to omega L sine theta B dx. Now total force on the surface is equal to P is equal to integral omega L sine theta B dx. Omega sine theta is constant, so we get omega sine theta integral L B dx. But since integral L B dx is equal to moment of the surface area about O and is equal to AX bar divided by sine theta, so put this value here and we get total force on the surface P is equal to omega sine theta into AX bar divided by sine theta. Sine theta will cancel out with sine theta and we get total force on the surface P is equal to omega AX bar, which is same as in the previous case when the surface is immersed horizontally and vertically. So total force on in each case is equal to P is equal to omega AX bar. Now we will solve an example on this. A rectangular plate 2 meter into 3 meter is immersed in a liquid in such a way that its latest and least depths are 6 meter and 4 meter respectively from the water surface. Calculate the total force on the plate. We have a plate whose area is given and area is 2 meter multiplied by 3 meters and it is immersed in such a way that the least depth is 6 meter. The greatest and least depths are 6 meter and 4 meter respectively from the water surface, and we have to calculate the total force on the plate. So first of all, write the given data. So in given data we have given the size of the plate, which is equal to 2 meter into, this is not 5 meter, this is 3 meter. Mistakenly it is written as 5 meter, it is 3 meter. And greatest and least depth is equal to 6 meter and 4 meter. First of all we will find the area of the plate. So area of the plate is equal to 2 meter into 3 meter equal to 6 square meter. And depth of the center of the plate x bar is equal to 6 plus 4 divided by 2 equal to 5 meter. Now total force on the plate P is equal to omega AX bar. Since the liquid is water, so omega is equal to 9.81. Area is already find out, which is 6 square meter, and x bar is equal to 5 meters. So putting the values, we will get the total force on the surface of the liquid, which is equal to 294.3 kilonewton. And this is the answer for example 3.5. Also, this is the end of our today's lecture.